Welcome back to another past paper walkthrough video. This is MEI Core 4, Section B for June 11. So let's get on to question 7, which is usually a vector plane equation kind of question. So you have this diagram which demonstrate the 3D graphics of this question. First part, write down the vector A to B, which is just this to that, and A to C, and hence calculate the angle of BAC, which is this angle. Then verify the equation of the plane equals to this, where D is a constant that you need to calculate. Then find the acute angle of the plane and the horizontal plane. And part 3, given that A, B, C, and D are coplanar, show that K here is 3, and hence show ABCD is a trapezium, which means that there are two lines parallel somewhere. And find the ratio between CD and AB. So there are 3 different things that we need to do in this question, part 1. So let's start with finding AB vector. So because we have the position vector of these, so the way to get the directional vector from A to B is to take A off and add B. So it is a negative A and a B. Similarly, for AC, it is a negative A plus C. So AB is equal to minus 2, 0, minus 3, add minus 2, 0, 1, and for AC it is a minus 2, 0, minus 3, add 0, 4, 4, which for this gives you minus 4, 0, and minus 2, and gives you AC equals 2, minus 2, 4, and 1. So that's the first 2 bits done. We need to find angle BAC. So the way to do this is to use the directional vector and apply dot product, which means that when you dot the 2 vectors and you divide by the magnitude of the vector, you get an expression for cosine of the angle in between. So this only works for directional vectors pointing away from the point where the angle is, and it always measures the minor angle, so the angle in between, that is the smallest. So for this one, the dot product of this vector and this vector is minus 4 times minus 2, add 0 times 4, add 1 times minus 2, which this result on the top bit, and the bottom bit is the magnitude. So the magnitude is always the square root of all of its components squared sum. So 16 is minus 4 squared plus 0 squared plus minus 2 squared, that's 4, and multiply that by the square root of 2 squared or minus 2 squared, which is 4, then add a 4 squared, which is a 16, then add a 1 squared, which is 1, and this will equal to cosine of theta. And by putting all these into the calculator, minus 4 times minus 2 is minus 8, plus minus 2 is minus 10, divide by, this is root 20, this is root 21, and they are not good numbers, so do not bother trying to simplify those, equals to cos theta. Actually, this is plus 8, so I made a mistake here. Plus 8 minus 2 is positive 6. And there, we just need to do an arc cos of 6 divided by the root of 20 times 21, which gives you theta equals to 72.97 degree, which is the equivalent of 73.0 degree. 3 significant figures. So that's part 1 done. So part 2, we need to verify that the plane equation is this. To verify this, we just need to find its normal factor and make sure that it is perpendicular to both AB and AC, so that the normal factor of the plane is perpendicular to the plane. So the dot product between AB factor will be equal to the dot product of the AB factor with the plane normal factor will be cos 0, arc cos 0 rather, because it's cos of 90 degree. So if AB dot of 1, 1, minus 2, because that's the coefficient of x, y, and z, is 0, and if AC factor dot 1, 1, minus 2 is also equal to 0, then it is a normal factor. 1, 1, 2 is a normal, 1, 1, minus 2 is a normal factor, and therefore this equation is the plane equation. So factor of AB is, as we have found, is minus 4. So minus 4 and minus 2. So the dot is minus 4 times 1 plus 0 times 1 plus minus 2 times minus 2, which is minus 4 plus 4, which is 0. So same for AC, so minus 2 times 1 plus 4 times 1 times minus 2 times 1, which is equal to 4 minus 4 equals 0. And so that's all you need to do to verify that step. Now what you need to do is to find D, so you just need to just randomly substitute one point in. So let's do point A. Point A is 2 plus 0 and minus 2 times 3, which is 6, plus D equals to 0, and by just doing the calculation, D is plus 4. And so the plane equation is just x plus y minus 2z plus 4 equals 0. So for finding the acute angle between plane and horizontal is just using the normal factors. because you have infinitely many plane factors that you can construct in a circle, but there's only one perpendicular normal factor for every single plane. Well, technically two, plus and minus, but they are on the same axes anyway. So let's find the normal factor for the plane, which is given as 1, 1, and minus 2. So that's convenient. Dot that with the horizontal plane, which is because the normal of the horizontal plane is just 1z, so it is a 0, 0, 1. All of that divided by the magnitude of it, so the normal factor of 1 is just 1, because it's 0 squared plus 0 squared plus 1 squared, and everything root. Then multiply that by the magnitude of the normal factor, which is 1, 1 minus 2. So that is 1 squared plus 1 squared is 2 plus 2 minus 2 squared, which is 4, so that is root of 6 equals to cosine of theta. And so we know that theta, using our calculator, is, first of all, let's find the top. That is 1 times 0 plus 1 times 0 times minus 2 times 1, so that is minus 2, divided by root 6 times 1, which is root 6. So theta, if you do arc cos of 2 minus 2 divided by root of 6, then you get the angle 144.74. Now this is not an acute angle because this is the normal angle. So if on the plane this is the angle that is acute, and the normal factors will not meet acutely. So this is the angle we have found using normal factors, and this is theta, and these two are normal angles, so are 90, and thus from using the quadrilateral rules, the sum of all of its internal angles are 360 equals to 2 times 90 plus whatever we got as theta plus alpha, which is the acute angle we want. So alpha is just 360 subtracted by 144.74 subtract by 180, which gives you 35.26 degree, which is 35.3 degree in 3 significant figures. So for this one, you just need to put in all the values of D, and because it is coplanar, it satisfies the same equation, so we can just find what the value of Z or K is. So in this one, it is in minus 2. Well, we use this equation. Minus 2 is X, plus 4 is Y, minus 2 lots of K, because K is the Z coordinate, plus 4 is equal to 0, and 4 plus 4 minus 2 is 6. So 2K is 6, and so K is 3. So that's proved. Now we need to show that it is trapezium on the plane. So we need to find the factor of C to D or B to D, depending on which side is the parallel side. And I'll make a wild guess that CD looks a bit more parallel than BD and AC. So let's do CD as a factor. CD factor is equal to minus C plus D. So it is 0 minus 4 minus 4. So add minus 2, 4, and K, which is 3, as we found. Or if you can't do the first part, you can just use its answer, which gives you minus 2, 0, minus 1, and turns out that this and the factor AB, which is minus 4, 0, and minus 2, is simply just 2 lots of minus 2, 0, and minus 1. And so, because they have the same directional factor, and the linear part is just the magnitude of it, so they are parallel. AB is parallel to CD. So that is a property of a trapezium with a parallel sides. So yeah, that's all you need to do for that part. Now we need to find the ratio of AB to CD, and just by looking at the coefficient, we know that CD to AB is just 1 to 2, just by inspection. So that's it for this part. So now let's get on with question 8. So this is a rate of change equation, kind of differential equation, and water is leaking from a container, and after t seconds the depth is x and the volume is v, where the relationship between v and x is a third x cubed. So the rate is proportional to x, and that dv by dt is minus kx, where k is a constant. So that's a mouthful of information that we need to interpret. And first, show that x dx by dt is equal to minus k. And initially the depth is 10 centimeters, so x is 10 and t is 0 because it's initial. Part 2 is show by integration that this is that, and part 3 given that the container empties after 50 seconds, find k. So that's simply substituting values and rearranging to find k. And once the container is empty, water is poured into it at a constant rate of 1 per second. That's v per t, so dv by dt is 1. The container continues to lose water, and show that t seconds after starting to fill the container, dx by dt is 1 minus x over x squared, and show that this equation equals to that combination, and hence solve the differential equation in part 4, this to show that t is ln of 1 over 1 minus x minus a half x squared minus x, and 4 show that the depth cannot reach 1 centimeters. So part 1, show that x dx by dt is equal to minus k. So what can we start? So let's start by decoding what the question asks. So water is leaking from a container. After t seconds, the depth is x, and the volume is v, where v is this. So we have a volume to height or depth relationship. So when you see that, it's probably a good idea to just differentiate that anyways, because you will use it. So dv by dx is equal to 3 times a third, which is 1 x squared. And the rate at which water is lost is proportional to x, and the rate of water loss means the rate of volume, which is dv dv by dt, which is proportional to x. Well, actually it's given on this side as well, so dv by dt is equal to minus kx. So in order to find an expression for dx by dt, we need to use these two, dv by dx and dv by dt, and cancel out the dv. So in order for dx to be on top, we take the reciprocal of dv by dx, so dx by dv is equal to 1 over x squared. Multiply that by dv by dt, we get dx by dt equals to 1 over x squared multiplied by minus kx. And the x squared and x cancels, and so it is now minus k 1 over x dx by dt. And to make it so that it looks like that, you just multiply both sides by x. So minus k is equal to x dx over dt. Part 2, we need to find this, show that x is equal to the root of 100 minus 2kt. So by integrating, the only thing that we can integrate is this expression. So by integrating this, and we are given the initial condition t is 0, x equals 10. So let's do the integration bit. So integral of x dx is minus k dt. This is just separation of variables. So integrate x by dx is just x squared over 2, and this is minus kt plus c, because there's a constant, and when t is 0, this term is 0, so c is equal to 10 squared over 2, which is 100 over 2, which is 50, and thus the expression is x squared over 2 equals to minus kt plus 50. And multiply both sides by 2 and swap these two sides so that positive is on the left, gives you 100 minus 2kt. And it's just simply rooting both sides to root 100 minus 2kt. And that's the thing that you need to show. So part 3, it takes 50 seconds to empty this whole thing. So t is 50 while x is 0. So let's put the values into this equation. 0 equals the square root of 100 minus 2 times 50, 100 k. And if we square both sides, we know that 100 is equal to 100k, and therefore k is just 1. So for this part 4, we need to consider both the increase in height per second and also the decrease in height per second, because there is a leak and it will lose water at the rate that is discovered, and it will gain water at the rate that is here. So let's see the loss of water is, we want to find dv by dt first of all, which is minus kx, where k is 1, so dv by dt is equal to minus x, and therefore by multiplying dx over dv, we get that dx by dt is equal to minus x divided by x squared, which gives us minus 1 over x. That's one part of it done, and we need to consider the adding side. And so the adding side is 1 is equal to dV by dt, because centimeters cubed is volume and second is time. And to find dx by dt, we do the same equation on that side. So dx by dt is equal to 1 over x squared, and that cannot be simplified. So the total dx by dt, the total change, is equal to the sum of both of these. So it is 1 over x squared plus the negative 1 over x, which is 1 minus x over x squared, which correspond to this value right here. Okay, so let's start by solving this bit. So we need to prove the left hand side equal to the right hand side. So let's start with just the left hand side. So 1 over 1 minus x minus x times 1 minus x over 1 minus x minus 1 times 1 minus x divided by 1 minus x, and this is exactly equal to that, and we can take it as a common fraction of 1 minus x. So I have 1 minus x plus x squared minus 1 plus x, and that the positive 1 cancels the negative 1, the negative x cancel the positive x, and we're left with x squared over 1 minus x. So that's straightforward. Now we need to integrate this expression to get a t in terms of x expression. So let's start by moving dt to the right. So integral of 1 dt, because there's no t here, and you multiply this expression to the left to get x squared over 1 minus x dx. And because we already have this expression broken out previously, so we can use that to make our life a lot easier. So 1 minus x minus 1, and this is t plus c. Add the constant add up together to the same side, so that's easy. So this side will not make any other constants because we can just combine it here. So the integral of this side will be equal to natural log of 1 minus x multiplied by negative 1, then integrate x is just x squared over 2, then minus 1 is minus x equals to t plus c. And we need to solve for c. We know that x is 0 when t is 0, and so c is equal to 0, 0 minus ln of 1, which means that c is just 0 because ln of 1 is 0. And so this is just minus ln of 1 minus x minus x squared over 2 minus x equals to t. But what we want is to have this expression, so the negative moves to the top as a power, so t is equal to natural log of 1 minus x to minus 1 minus x squared over 2 minus x, and that can be multiplied inwards the natural log of 1 over 1 minus x squared over 2 minus x, which is the same as this expression. And finally, for part 6, I'll just add right here, show that x cannot be 1, the height cannot be 1. Well, if x is 1, then ln of 1 over 1 minus 1 is the ln of 1 over 0, which is not possible. And that's all you need to say for the last mark. So that's it for this paper. And that's it for this part for section B. And this core 4 paper is not that bad because everything is just textbook questions, especially this plain factor question. It's really straightforward. If you have done enough of factor questions, then you should be able to just do that. This, on the other hand, is a bit more tricky, but it's still a very typical rate of change question. So if you've done enough practice, then you should not be worried about this at all. So yeah, that's it for this core 4 paper walkthrough. Thank you very much for watching, and I hope you've learned something, and I'll see you on my next one.